This is Mrs. Erickson, and this is the famous Dr. John. He's a doctor of science.
Today we're doing an experiment we're calling the popcorn lava lamp. It's sometimes called the magic dancing popcorn. For this experiment, you'll need 2 tablespoons of baking soda, 2 cups of water, and 1 cup of white vinegar.
And don't forget the popcorn.
The popcorn unpopped. So first we will put the 2 cups of water in a glass container like this so you can watch what's happening. Then we'll carefully mix our baking soda.
I know what we forgot, Dr. John.
What did we forget? Oh, very important. This experiment can be messy, so it's best to have some kind of container to contain the explosion. So we mix it up. Baking soda in water forms a solution but doesn't dissolve, so it'll look cloudy. Next,
So the baking soda stays as a solid in the water.
sometimes it's called a suspension. That's a scientific word. Now we'll pour in our popcorn and nothing happens. Nothing happens. What's going on? Look, it's just sitting at the bottom. Nothing's happening.
Dr. John, what's the problem?
I know what the problem is.
We don't have a reaction.
How do we make a chemical reaction? We are going to pour this vinegar in. The vinegar is going to mix with the baking soda that's in suspension. It's going to form a reaction. It's going to make gas bubbles. And surprise, surprise. Oh no! Look at all those bubbles. And look at what's happening with the popcorn. Each one of these little kernels of popcorn has bubbles all around it. Those bubbles came from the baking soda bits mixing with the vinegar, forming a chemical reaction, producing a gas called carbon dioxide. The carbon dioxide joins up with whatever it can, which is the surface of the kernels, and they go up and down.
Shall we move it closer so they can see?
Look at them.
Just like a lava lamp.
Just like a lava.
If you don't know what a lava lamp is, ask your parents. Ooh. I have a challenge for you. I want you to time how long these will go, up and down, up and down. I think it will have to go for a pretty long time. What do you think, Dr. John?
I think it could go for hours. What will happen is these will slow down. It'll look like it stopped. But then if you add a little more vinegar, just a tiny bit of vinegar, watch what happens. It bubbles some more. This could go on all evening. What's happening is your initial pour of vinegar combines with some of the baking soda, makes the bubbles, but there's still baking soda left mixed in the water. You add more vinegar, more bubbles form, and it just keeps happening and happening.
So we're going to let it sit and see how long it goes for. And we'll be back after a certain amount of time to see if it's slowed down any.
20 minutes later, and it's still going strong. It's slowed down quite a bit because the vinegar that we poured in has combined with some of the baking soda, but there's still baking soda left to be combined with. But it's still going strong. Look at it going up and down. What's making them fall is the bubbles cover the surfaces of the popcorn kernels. They rise. When they get to the surface of the liquid, the bubbles pop and they fall back down.
I have an idea.
What's that?
Let's try using seltzer water and see if it will make the popcorn dance.
That's a good idea. Seltzer water has carbon dioxide bubbles in it. Let's pour our popcorn in. Here we go. It's fizzing just like our, oh, look at that. It's working. It's dancing exactly like our vinegar and baking soda.
No explosion though.
Ah, a lot less messy that way.
I wonder how long this will last.
This will. So now you understand why those little bubbles form at the side of your glass when you pour soda like Coke or ginger ale or whatever it is, or seltzer water into your glass. The little bubbles are collecting on the sides, and if you put popcorn in,
it makes a lava lamp.
Well, we hope you enjoyed this experiment, and we have a lot more planned.
And try it at home.
Be careful.